We're getting ready to do lesson 8.4 part 1 today of pre-calculus math classwork lesson. In today's lesson you have 14 points on your notebook sheet. If you don't have notebook sheets, email me to get those. And then we got 44 points here on your classwork sheet. Email me for those if you don't have them. And students in my classroom, name, date, period. And then if you're online or if you're a homeschooler, please put your due date in there. And let's go into our bell work. Students, teachers, here's today's bell work. We have find the inverses of these matrices. Teachers, give your students about 5 minutes for that. They should be able to do it then. Pause your video. See you in 5. Okay, welcome back for our solutions for today's bell work. The inverse of this matrix up here, this 2 by 2, would be we're going to use this method here of using this formula. So the inverse of A will be, we stick this down into our denominator and then we multiply that by the template that's used to find your inverse. And then we come out with 1/2 equals this here, which comes out to 1, 2, negative 1 over 2, then negative 1 over 2. This should be the inverse of A there. And then down here we use the same method again. We use our formula for finding our denominator by going 11 times negative 2 minus 2 times the negative 12. That goes in our denominator. And then times our template that we use to multiply this by that. And if you remember back into chapter 7, we come out again with 1 over 2, and then we multiply that by this, and we come out with this as our inverse of A, negative 1, 6, negative 1, 11 over 2. So students, that's what you should have. If you don't have that, self-correct, or pass it back to your study buddy with the corrections on there. Into our lesson today, page 1, we'll go into your notebook here, binomial coefficients. Recall that a binomial is a polynomial that has 2 terms. We have binomial here. In this section, you will study a formula that provides a quick method of raising a binomial to a power. To begin, look at the expansion of x plus y to the nth power for several values of n, and then here is an example here, and we keep growing here on our terms for each power of this quantity here. We increase our number of terms here. So this is a general template here of binomial expansions. There are several observations you can make about these expansions. One, in each expansion there are n plus 1 terms. So for 2 here we have 3, and then for 3 we have 4. In each expansion, x and y have symmetric rows. The powers of x decrease by 1. The powers of x decrease by 1, and whereas the powers of y increase. So x decreases and then y increases here. No y here, y1, y2, y3. So there is a symmetry here. 3, the sum of the powers of each term is n. So the sum here is n. This is a cube, this is a square, so if you notice that. For instance, in the expansion of x plus y to the 5th, the sum of the powers of each term in that case will be 5. So there you go. There's some more of your symmetry. Okay, and then here, for x plus y to the 5th, we have 4 plus 1 is 5 here, 3 plus 2 is 5, 2 and 3 is 5, 1 and 4 is 5, 5, and then 5. And x decreases, y increases. The coefficients increase and then decrease in a symmetric pattern too. You have 1, 5, 10, 10, 5, 1. The coefficients of a binomial expansion are called binomial coefficients. To find them, you can use the binomial theorem. So what's the binomial theorem? In the expansion of x plus y to the nth power, x plus y to the nth equals x to the n plus nx n minus 1y plus dot 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 ncr x to the n minus r y to the r plus nxy n minus 1 plus y to the n. So there's a lot of symbolic language there. What does that mean? The coefficient of x to the n minus r yr is ncr equals n factorial over n minus r factorial. Again, a little bit more symbolic language. The symbol nr is often used in the place of ncr to denote binomial coefficients. So we're getting here to finding our coefficients of a binomial expansion by using this kind of method here, the NCR, n choose r method. Isn't our way of saying that? So let's try one now. Example 1, finding binomial coefficients. So A here is 8c2. So for that one, 8c2, 8 factorial, plug this in now into our formula. We crank this out, we cancel where we can, and we come up with 8 times 7 over 2 will be 28. And then B here, 10(3), would be the same thing as 10(3). It would be 10 factorial over 7 factorial times 3 factorial. We factor this out here. We cancel out our 7s. We end up with 10, 9, and 8 over 3, 2, 1, which will equal 120 for this binomial here. And then for 7c0, 7c0 will be 7 factorial over 7 factorial multiplied by 0 factorial. Here's our 0 factorial, which will equal 1. This is 1 and this is 1, so it'll be 1 over 1. And then D would be 8 over 8. So for that one, we have 8 factorial over 0 factorial times 8 factorial. Again, will be 1 for this one as well. Let's try one. Find a binomial coefficient of these. We're going to do this one, students. This is on you. So pay attention up here. So for 7, choose 5. We have 7 factorial over 2 factorial, 5 factorial. You factor this down, these cancel out. We end up 7 times 6 over 2 would be 21 for 5. And when r does not equal 0, in this case here, when r does not equal 0 and r does not equal n, as in parts A and B of example 1, there is a simple pattern for evaluating binomial coefficients that works because there will always be factorial terms that divide out from the expression. So for example here, we have 8c2 will equal 8 times 7 over 2 times 1, 2 factors here, and then factor this down to 2 factorials, and 10(3) will be 10, 9, 8, and then 3, 2, 1, and we have 3 factors here, and then 3 factorial down here. So if you factor those back like that, that'll help you find your coefficient. Finding binomial coefficients, so 7c3. So if we factor this out by 3, 2, 1, here's our denominator 765. So these two will factor down. 3 times 2 is to be the same thing as 6 factorial. So you end up with 7 times 5 over 1. And then here we have 7c4. Again, and when you break that down, we have 4, 3, 2, 1, and then 7, 6, 5, and 4. This will factor here. These 3 will factor, and that will factor with that. So again, you end up with 7 times 5 over 1. And then this one here, 12c1, will just be 12 over 1, by the way. And then for D here, 12, choose 11. That would be factoring, again, 12 times 1 factorial times 11 factorial. And then 11 factorial here, 12 times 11 these will factor down, and you just end up with 12 over 1 factorial would equal 12. So let's try 1. Find a binomial coefficient of this and also of this down here. That one's on you, students. So for this one up here, 20 over 15 times 5 factorial. We factor this back to 12, 19, 18, 17, 16, 5, 4, 3, 2, 1, because everything over here is canceled with that. So we just end up with our 5 factorial here. And we end up with this number here for our binomial coefficient. Students, that one's on you. It is not a coincidence that the results in parts A and B of example 2 are the same, and that the results in parts C and D are the same. In general, it is true that NCR equals NC and minus R. Binomial expansions. As mentioned at the beginning of this section, when you write out the coefficients for a binomial that is raised to a power, you are expanding a binomial. The formulas for binomial coefficients give you an easy way to expand binomials as demonstrated in the next 4 examples. So let's try one now. Example 3, expanding a binomial. Write the expansion of this expression here. So the binomial coefficients now, 3 choose 0 would be 1, 3 choose 1 would be 3, 3 choose 2 would be 3, and then 3 choose 3 would be 1. So here's our expansions here, 0, 1, 2, 3. Therefore, the expansion is as follows: 1, 3, 3, and then 1, and then we follow in with our manipulations here for our x. And so our x is 3, 2, 1, and then 0 over here. So it does that in reverse here, 3, 2, 1, and then 0 over here. X to the 0 power would be 1. So x cubed plus 3x squared plus 3x plus 1 would be the expansion of this expression here. Let's try one. Use the binomial theorem to expand and simplify this expression here. X plus 2 to the 4th power. This one's on you, students. X plus 1 to the 6th power. Let's try x plus 2 to the 4th. So we have 4c0 x to the 4th plus 4c1 x cubed 2 plus 4c2 x squared 2 squared, 4c3 x to the 2 to the cube power, and then 4c4 times 2 to the 4th power. And then when you expand this out, you come out x to the 4th, 8x cubed plus 24x squared plus 32x plus 16 here. So that would be your expansion from this. And you do the same thing down here, students. Okay, hint, hint. Okay, onward to our next example here. Expanding a binomial. Write the expansion of the expression x minus 1, 3. Now we have a difference here. Expand using the binomial coefficient from example 3. So we're going to separate off this -1 here, cubed. To expand binomials representing differences rather than sums, you alternate signs. So we end up with this x cubed plus 3x squared -1 plus 3x -1 squared plus 1 times -1 cubed. And then this will yield x cubed minus 3x squared plus 3x minus 1. And then we'll try it again here with this difference. And students, this is on you with this difference. So for 27 up here, you start out here with 3 choose 0 y cubed minus 3 choose 1 y squared 4 squared. This is our 4 here. And then we have plus 3 choose 2 y times 4 squared minus 3 choose 3 4 cubed, which will break down to being y cubed here, minus 12y squared. See, 16, 3 choose 1, 12y squared, plus 48y, and then minus 64 over here. And that is your 8.4 Part 1 pre-calculus math. Email me here for class worksheets, homework sheets, note-taking guides, homework guides, solution PowerPoints, any other course materials, animated PowerPoint math video at AOL.com. Thank you.